Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining OSPF stub areas. OSPF uses the concept of areas to introduce a hierarchical structure to an OSPF topology. Each area learns about external routes as well as routes from other areas. Sometimes it's possible to define some of these areas as what are known as stub-type areas, in order to reduce the amount of routing information overhead within the OSPF domain. Stub area types in OSPF limit external route flooding to reduce routing table size and complexity. And depending on the type of stub area, they may also block external routes shared in Type 5 LSAs and inter-area routes shared in Type 3 LSAs. Instead of specific routes to these destinations, stub-type areas rely on a default route that's injected by the ABR to reach destinations outside of the local area or outside of the OSPF autonomous system. This results in much smaller and much more efficient routing tables and link state databases, as well as far fewer LSA exchanges, smaller LSA sizes, and less LSA flooding. There are four main types of stub areas that can be configured in OSPF. Each one serves a slightly different purpose, and we'll go through each one to see how it should be used and how they make OSPF more efficient. The first stub area type is simply called a stub. This can be thought of as a standard OSPF stub area or simply a stub area. In this topology, Area 1 is configured as a stub area. There are certain rules that are adhered to when an area is configured as a stub. The first is that no Type 5 external LSAs are allowed within this area. In other words, if we have R2 here in Area 0 with a route to 10.2.2.0/24 being redistributed into OSPF, when that update reaches R0, it will not send a Type 5 LSA to R1 informing it of this external route, as would take place under normal circumstances. This is not allowed in our stub area. Instead, it will inject a default route and advertise that to R1 to deal with all external routes. The second rule is that no ASBRs are allowed within a stub area, such as Area 1. So we would not be able to redistribute an external route on R1 into OSPF because that would make R1 an ASBR. If we did that, the network would not be advertised to the rest of the OSPF domain. Notice, however, that Type 3 LSAs are allowed. That means that this 10.3.3.0/24 network will be advertised to R0, and it in turn will advertise it to R1 using a Type 3 LSA. So this network will appear in R1's routing table. So that's a regular stub network. No Type 5 external LSA is allowed, and no ASBRs are allowed within the stub area. But Type 3 LSAs, or summary LSAs, that advertise inter-area routes are allowed. Let's go on to the second type of stub area. Now, as we go along, you're going to discover how creative network engineers get when naming these stub networks. The first was simply called a stub. The second is called a totally stub area. What's that? Well, it has the same rules as a stub area, but it adds one more, making it not only a stub area, but a totally stub area. It's stubbier than a stub area, whatever that means. It too doesn't allow any Type 5 external LSAs nor ASBRs within the area, but it also does not allow any Type 3 summary LSAs in the area either. What does that mean? Not only will this external route not be advertised to R1, but not even this inter-area route will be advertised to R1. Both of these will be replaced with an injected default route to R0. As you can understand, this makes R1's routing table smaller, and it makes the number of advertised LSAs fewer, making this area more efficient. So that's a totally stub area. Now, the next two areas are a result of an attempt to add an ASBR to a stub area and to a totally stub area. In other words, the next two stub area types relax the ASBR rule. Let's take a look at the first of these. Now, this is called a Not-So-Stubby Area, or an NSSA. Really creative naming. So this is the same as the stub area, but without the rule of no ASBR allowed. So no Type 5 external LSAs are allowed to enter the Area 1 NSSA, but Type 3 summary LSAs are allowed. So for example, you would see this network here in R1's routing table. So R1 would be given a default route to R0 for all external routes learned by the OSPF topology via the R0 router. That's the same as a regular stub area. But now we are allowed to have an ASBR. And R1 here is an ASBR because this network is outside of Area 1. And it is then redistributed into the OSPF domain in R1. Now, since no Type 5 LSAs are allowed within Area 1, R1 cannot advertise this external route using a Type 5. So it will generate a Type 7 LSA to share the external route into the NSSA and beyond. So this is the NSSA type, which essentially takes advantage of the benefits of a stub network, but allows the use of an ASBR. Finally, let's go to our last and most interestingly named stub type. This is the totally not-so-stubby area. So this is the same as an NSSA, but ABRs are allowed. So like an NSSA, the external Type 5 LSAs and the intra-area Type 3 summary LSAs are disallowed. But R1 can act as an ASBR, injecting this route here into the OSPF topology. The result is that R1 receives a default route representing all of these networks here that is pointing to R0, but it is able to share this external route with a Type 7 LSA to R0 and to the rest of the OSPF topology. Now the question remains, why are these OSPF stub type areas useful? Well, the truth is that it's difficult to see their usefulness in topologies such as the ones we've examined. Their benefits are only seen at scale. This means that you will begin to see the benefits of stub type areas when you're dealing with large OSPF networks, where hundreds or even thousands of external routes are being injected, either from other routing protocols, redistributed static routes, or redistributed connected routes, as in our examples. Such large networks may have dozens of OSPF areas and a large number of ASBRs in various types of non-backbone areas. In these scenarios, reducing the amount of routing information that routers need to process becomes a huge advantage. For example, think of a network with dozens of branch offices where each branch office is assigned an OSPF area. Each branch doesn't need to know about every single external destination. It just needs a default path to the core, and that's exactly what a stub area provides. It says, don't send me every detail, just give me a way out. And that's where the different stub types come in. They offer fine-grained control over what kind of routing information enters an area, allowing us to balance functionality with efficiency. Let's say that we want to add an ASBR to Area 12 here. We can make Area 12 an NSSA or a totally NSSA and still benefit from the reduced routing table and LSDB sizes, and the smaller LSAs and the less LSA flooding, while injecting an external route to this particular OSPF area. So you see, each stub type has a specific use case, and as your network grows, understanding when and where to use them becomes a powerful skill. So that's it for the OSPF stub area types. I hope you found this video useful, and if you have, I would ask that you consider using the YouTube Super Thanks feature to say thank you and support my effort to simply explain telecom and networking. As I'm always striving to improve my videos, the funds will be used to support better equipment, better quality, better video editing services, and just to produce more useful training content. As always, check out my website where very soon you'll be able to find in-depth courses with labs, quizzes, and exams to test your knowledge and prepare you for certifications, as well as for the real-world networking and telecom industry. And don't forget to subscribe to the channel to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this video has been helpful for you, and I'd like to thank you for watching.